guys, welcome back to the channel. I have probably an interesting video. Let me just tell you what is going to be in the process of the video. So this is for a customer, Ryan Dean and Lenny Cook. His computer was not repairable at the port side. I had some issues with the injector drivers that end up being not the drivers all the way to the microprocessor. And on these boards, it's just impossible to replace that microprocessor. It will rip the little pads under it. So it's not repairable. So I help him out to find a donor module from, sources, and they bought it and sent it over. So we're going to test that module, and it's not really the same calibration that he has. So we're going to install his calibration on this computer. But before we do that, I want to make sure that this computer is good, right? So we're going to do the same test. I'm going to put the video of the test that I did with the real injectors, which I have right now behind me here connected as well. Since this computer, well, let me just say this is a PCMBE0101 from 2001-2002 Merc Cruiser. And these computers, that's the family. So as long as you got the same computer family, I can change the calibration from, let's say like this one is a 200 DFI, which is an Optimax 3.0. But Dean or Lenny's is an 8.1-496. So as long as I have the calibration, which I have plenty of them, I can then move that calibration over to this module. That in the process to do that, I need to open the module, connect it over to a tool, and get the flash and the EEPROM, and then transfer over to that. So that's what I'm be doing, or will be doing, if the module tested as good, because we need to make sure it's good first. So as I normally do, I had everything connected. Let me actually turn my meter on, because we need to make sure that the firmware reference is good as well. Make sure that meter turns on first before I open the software, but I think it's already there. So yeah, I need to wait for that one. All right, it's on. Let me just add an instrument because I went too fast. Looks like I finally read it. Okay. All right, let me make sure you have it in the screen. And you do. Well, actually, I'm going to do something different, because we're going to do, well, I want you to see that we have indeed a firmware reference in the sensor ground. That is good. So the computer, at least on that section, is good. So the next thing that I want to do is I'm going to move you over to my screen recording. This is a little hard to see because of the way the harness is built. It's a little tight. The way I move a little bit of the things in here. But yeah, this is a PCMBE01, and it looks pretty clean. So well, hopefully everything is good. And now I'm going to move you over to the screen, which actually perfect, because I can have the firmware reference and everything in there. Let me make that circle a little smaller. Like a little too aggressive right now. Make my circle a little less size. Yeah, that looks a lot better. And let's come back over to where we were, which is here. So in here, what I did is I already connected to the computer, and we're going to do the tests on each injector. Since this is a 200 or, a B6 3.0, well, there is only 6 injector drivers, or at least the test can only test 6 injector drivers, because for that calibration, that's all it is. So it's a little bit limited, because I cannot check that all, the other 2, even though they're built into the computer, but they have never been used. So I would not suspect to have any issues on that, right? But let's do the test on each. So right now I'm connected into injector number 1. And for those that have not seen the first part, which I'm going to, or the part where I do that, which I will put the link of that video in the description of this one. When I was doing the test on his, the test reaches from 0 to 100%. And in his, most of the drivers were stopping at 29%. Only 2 were reaching the 100%. And that I tried to replace, and I did one, replace one of the drivers, and it did exactly the same thing. Went over to the pre-driver and did the same thing. Check all the all the resistors in place as protections and capacitors are in place. No problem. I mean, it was everything good, and that's why the microprocessor was bad. But let's see how it's reacting on this one. So I'm going to click the on switch. We can see the activation on the oscilloscope on the right side, but we can see that we reached 100%. So I'm going to move now because I'm only using one channel on the oscilloscope, and that's good enough. So let me move it over to the injector number 2. If I can find it, 7, 2. All right, so now we're in number 2. I'm going to click on the number 2, and we need to see that reaching the 100%. Again, another good one. All right, let's do number 3. The signature looks pretty good. If it passes the 70%, I know that it's going to reach the 100%, so that is looking good. Let's go to number 4. Looking nice and even, everything looking really good. Perfect. So let's go over to number 5. Excellent. So far it's looking really good on this computer. And then do the last one, number 6. Excellent. So all those drivers are working excellent. Perfect. So we're going to exit. I'm going to exit that. I want to show you now, like in here, this is Diacom Rinda. If you have a boat and you want to have the best diagnostics that you can have for your boat, get the Rinda Diacom Windows based. Don't buy the TechMate. That's just a code reader. It gives some information, but you cannot record or do anything. With this one, you have a lot of capabilities. All right, so in here we can get into tests. So the upper menu is right here. So this is like how you will start in the software. But you can click on the upper section and then go over to codes, which this computer had some code. Let's see how many hours are in it. Let me run 500 hours, which is not bad. Definitely not bad. As I mean, I've seen this one with 2,000 hours. So 700 seconds of horn output, low oil reserve. Again, nothing that worries me. No, the injector openness because they're not connected in here. The pitot, the oil. Okay, that's actually not a problem in there. All right, so in here on the test tab, we can click on the system information, and that's going to read the EEPROM from the computer to see what the maps are in there, and it's going also to show us the calibration. So in here, there is a lot of good information for technicians, like you can have the resistance on the direct injection because the 200 DFI and this computer has drivers for direct injection and normal injectors. So the direct injection is 1 to 1.6 ohms. The fuel injector, 1.7 to 1.9 ohms. So that's a very good information to be doing the test as a technician. It tells you the values of the throttle position sensor 1 from 0.19 to 1 volt at idle, and then 3.45 to 4.63 wide open throttle. So you see, it's a lot of good information. But besides that, on the top, this first line right there that I put in blue, it says 3.0 200 DFI ECM A5961000, 099. That's the calibration number for this computer as is. So I want you to see that. So I'm going to connect to the computer. So let's just start from scratch. In this one, when you open the software, this is going to be your landing. When you have Mercury outboard, which that's what that software or computer is for, we have to click at the bottom where it says Mercury outboard, double click, and that opens this one. So you can see which is the PCM 555 and the ECM 555. That's what I have selected. There is others in here, but we're working with the Mercury. All right, so I click OK, and that's going to now connect to the computer. So I have different values in here. There's probably some temperature or something because I have 65% available power. Let me see. The temperature doesn't look that bad. Make sure, yeah, the blood pressure doesn't look bad either. Maybe it's based on the code. So let's erase codes. And we did have some codes, yes. Right now, as you can see right now, we have 100% power. You see right there, 100% power. That means it's good. And yes, I have, done faults because I don't have the direct injectors connected. I'm not going to do a test for that because we're not going to be using those for this calibration. All I care is the real injectors. And I don't want to run either the computer because the cam and crankshaft position sensor signals are in a completely different pins and everything. So it's a completely different beast, let's say. It went down to 65 again. Let me see what the fault codes are now. Oil, oh, yes, I know what that is. So is the oil level. I don't have it connected to ground, which is the oil level sensor. Give me just 1 second to see if I find it here. I think it's this one. Just to make sure that I can get rid of that fault. All right, so let's erase the fault codes. You see the oil level, engine low. That's a very important. You see right now it says engine level low is inactive because I did that and now we have again the 100% power. Give me 1 second, guys. Sorry about that. You see right now we have the 100% power. So yes, by not having that connected in here, and that is very specific to that calibration. Again, that is not even connected on the 496. But yeah, so you can see that the computer is reading really good. And this is what I'm doing in here, testing, make sure the computer, at least the hardware that it was for this is not damaged. And the main concern for me is the injector because those 6 injectors will be used for the 496. So right now, what I'm going to do is disconnect the computer, open it up, make sure it's clean, it's no corrosion, and then we can go from there because right now it's not even open. So let me actually power this off. And let me disconnect from Diacom. Like that, I can now disconnect. I'm going to move you back to this view. Plugs are very tight. A little weird angle to unplug them. And now you can see the computer in a better view, or in a better view. Let me get a zoom. All right, so again, this is the family of the computer, PCMBE0101, and this is from 05/30/2001. The computer part number, this is the part number in case somebody wants to buy one. And the calibration, as I mentioned before, is A59610099. That's a 200 DFI, as we saw in the software. So, sorry, forgot that we were in a Zoom. But yeah, so that looks okay. So right now I'm going to open the computer and I'll be right back. All right, guys, I opened the computer and it looks in really, really good shape. Definitely no signs of corrosion. Probably a little too bright for you, huh? But I need to see, but I mean, definitely looks like really, really good. Computer is nice and clean. And it's in pretty good shape. So Ryan and Lenny, I think we have, or you guys got a very good computer. I am making no money on the module. I actually send them directly the link for them to pay for. So all I'm charging the customer here for the test and for the calibration transfer. That's it. But the rest is all still the same for them as far as the price if they pay for the module. All right, guys. So in this one, again, let me connect my tool. I'm gonna have to read the file and then transfer it, and I'll be right back. All right, guys, I transferred the calibration. Everything went well. So let's do the time test. But now we'll see all the injectors actually working, and then we'll run the computer for sure. Actually, I need to put the correct cam and crank correlation. Give me 1 second. Let me actually show you how that one is done. Here, you get it better. So this is for the MSC 12,000, which is the simulator that I use to inject the signals for the cam and crank. And I have created my own, so I know exactly where to go, right? So this is just pretty simple. All you do is select the waveform that you have created, and then that transfers it over to the simulator. I like this simulator because of that, because I can write my own signals. Actually, I went probably too fast for you, but let me just show you the software 1 second. So, because I know there is a lot of guys out there looking for this. So you can do so signal editing, and in here you got 10 channels, actually 11. The 8, 9, 10, and 11 are AC sine waves, and you will see if I click in here. Let me see. No, it's not letting me click on it. Oh, right now it did. Okay, so probably I was just, you see that is a sine wave. I click in here, it's a square wave. So that's how you create your signals. You have to copy and count the teeth. It is a time-consuming process, but once you do it, it's done. All right, so we're going to click on the computer. Let me just show you on this view. I'm going to power it off completely. I want you to see the main power and the field pump relay. So main power is on. Field pump relay comes and goes off, which is the normal way of that. And then let's go back to here. We select Mer Cruisers 2001 to 2009, and that will connect to the computer. All right, so we got 100% power. All the PIDs are selected properly. Let's go over to test. Let's check first the system information. Sorry, as we did before. But now we can see that is, come on. I have to connect to the computer. Yeah, let me connect to the computer. Let me actually show you, because I haven't shown you that indeed we still have the same computer that says it's still 200 DFI right there. Now let's go back to that. Again, in test, system information. And in this one, sometimes it doesn't read it. Come on. And your location and port. And I was reading it properly. Now it's giving me an error. Let's run it. Because sometimes, oh, actually, no, let's do the injection test first. We're going to do the same thing. And I'm just going to, without even putting, well, actually I can because I have it here. So let's do it the right way, right? Since I have everything connected. So let me go back to injector number 1. That's the only thing I didn't want to do, because I have to find each injector. When I have it connected up in the top, it's pretty easy because they're all in the correct spot. Right now, there are just wires in here. So let's just start in order. Injector number 1. Come on. And all we really need is to see that it reaches the 100% on the test. And now you can see that it has 8 injectors. That's already telling us that we're in the correct calibration. No doubt about it. Well, let me move this to injector number 2. It's doing that. All right, so that works out good. Let me move this over here and put that one there. See if it does stay. All right, let me move it over to injector number 3. It keeps doing the same. All right, I guess I will click on that image every single time. Oh, I know why is that. So what I got to do is when I click in here, I'm going to make this one a small. Let me do it one more time. Select that one in here. And now I can go over to the injection. Perfect. I think it will work. All right, let's do number 4 now. And we know that these ones are good because we already did it. But Let's redo it again now that we have the correct calibration in the computer. All right, let's go over to 5. Definitely looking, I can hear the injectors open and closing, and looking at the waveform, that looks pretty good. Number 6. And I'm using, again, real injectors. Because when I use the simulator, it's not really the correct load, and the computer knows it immediately. All right, so the last one that we couldn't check before because of the calibration, so I'm going to do number 7. And those drivers are brand new, never used, right? Because that was a 6-cylinder calibration. Excellent. And then last but not least, injector number 8. Then I'm going to move the frequency for the cam and crank so we can run that computer quickly. All right, so that passed the test. So let's go over to here. I'm going to reconnect to the computer. And I'm now going to inject the RPM signal. I'm just going to put that in there and let's run it. All right, so let's run it. I got to increase the RPM. And I can hear the injectors. Just remember, we still got it. You can see the signal in there. The injectors are running all good. We got 100% power, which is great. Let's see what codes are we getting. EST 7 and 8 are not connected. I have this simulator only has 6 coil drivers for the triggers, like in this type, and for the regular coils only 6. So I'm not sure why you have 8 injectors and only 6 coils, but that's the way they build it. So that's why those are open, and I can transfer those wires over, but I already tested outside the video and I know they're good, so take my word. And this is running really good. So only thing we have not seen in this test light that I have right here is for the IAC driver, but these IAC on this calibration don't operate until it reaches certain speed. So let me put that in here. Let me make now that big. I'm going to put that on the screen, so give me 1 second. All right, I got everything ready. Let me put the meter up in the top so we can see the fiber reference as well. Okay, so the IAC does not operate on these ones until you reach certain RPMs. So let's increase the RPMs. We can see more pulse of injectors in there. And let me change. You can see now it's starting to operate, and that is completely normal. Let me change the throttle to around 25%. I can see it on the values in there. Everything is looking normal. And also increase the manifold air pressure around 10 psi. Everything is good. All right, we got 42% power. Let me see what we have in here as far as why the power went down. Let's go over the codes and read the full codes. EST, low dry lube. Okay, so that will definitely immediately create a problem. And that is not connected. Actually, I think I need to unplug this one here. Let me erase the full codes. So that definitely will diminish the power. And even though it shows 41%, well, still shows 41%. Let me see. Oh, yeah, the oil pressure is a little on the low side. Erase 4 codes. Guardian is active. Guardian is active. Let me see what is triggering the fault. Temperature maybe a little too high. Manifold temperature looks good. Lexi temperature looks good. IAC is okay. C pump pressure is good. Let me erase that. Why is the Guardian coming on? Fuel level, Lexi temperature. Let's connect that one back in there. Let's go down to idle. Yes, as soon as we pass the RPMs, so let me go back. Right now we have 100% power. Didn't change anything, just connect and reconnect the low oil lube and change the temperatures, right? So sometimes, and this is very common on these computers, you see right now the Guardian is inactive. So it was because of temperature. Nothing wrong with the computer. I just got it onto too high of a temperature, so the computer wasn't happy. I'm like, oh, whoa, we're too hot. 178 is already considered too hot. So let's cut the engine power. Like that, we don't damage the engine, right? So that's exactly what we saw in there happening. But right now, in 3,500 RPMs, we have 100% power, and you can see the IAC now fully nice and bright, and it's only at 32%. And if I increase the RPMs more, you can see now it went to 83%, completely a lot brighter, right? So we're right now in 4,400 RPMs. The IAC duty cycle is on 83.5. So this computer, Ryan and Lenny, is 100% working, and everything is really good. I'm very happy the computer that I recommended, because that's, it's a little hard sometimes to recommend something because it's a used computer. The guy that we purchased has 100% reputation, and that's what I went that way, but I have never purchased anything from him. So I tell Lenny and Ryan, you buy directly, because I don't want to be involved in case something happens, because if I put the calibration and then something is bad, we can return the computer, but it's out of my hands. I don't want to deal with that. But at least everything worked out perfectly. So as you guys can see now, everything is working really good. Let me go down into idle again. I'm looking at the pits myself, faster right way. I want to go in between 7 to 10% on the throttle, and then the map, I keep it at 6.10 for this 496 at idle. Again, those are my own values. Disregard the jumpings on those values a little bit up and down. That's the power supply on this one. I already know that, but everything is working good. Let me kill the RPM. Let's see if we can now read the system information, because sometimes it's not going to let us. You see, it's not. Let me cycle the key one more time. Sometimes this computer, the PCMBE0101, they're tricky. Sometimes they let you, sometimes they don't let you. You see? And it's nothing I can do with that. But we saw for a brief of a second, and I'm glad that I captured that on the video where it was reading the calibration and everything, and this is perfect. So no doubt about it. All right, guys. I'm going to stop the video here, call Lenny, seal this computer, and then get ready to ship. If you have any marine, automotive, computers, instrument cluster, I'm your best company. You are in the best hands. There is no other company in the world that does what I do about showing you the before and after, the process of testing your computer, reproducing your concerns, giving you the peace of mind that when you connect that computer, you are good to go. There is no other company that does that. And it's always limitations with the simulators, but I'm trying to narrow those to almost none. Like that, when I give you something, is good to go. But on vehicles, like especially automotive, that has 50, 60 computers, it's always that signal that I cannot reproduce in here, that is impossible. And I always tell that to the customers that, it's always this limitation. Here, everything is working good. That's all I can say. It's giving you a clean bill. Yes, a clean bill here that you have to test in the car and get your data. I cannot get you the data because I don't have the car, right? So that's the only difference. And guys, if you're here on the channel, please don't forget to subscribe. I'll see you next time. Bye-bye.